Welcome to Concepts in Chemistry. In this talk, we will discuss how to solve some density problems. To start, we have two questions here. The first question is saying, if the rectangular block's mass is 2.52 kilograms, calculate the density of the block. So first, to solve this problem, we need to know the mass of the block, and we also need to know the volume of the block. So the mass of the block is given, which is 2.52 kilograms. And we also need to find the volume of the block. To find the volume of the block, since this is a regular block with well-defined dimensions, we can easily find the volume of the block. Since we know the volume of a rectangular block, it's calculated by multiplying the width by the length by the height. So we have the width here, which is 5.1 centimeters. We have the length, which is 1.08 meters. And we have the height, which is 6.2 centimeters. But if you look closely, you notice that the length is in meters, while the width is in centimeters and the height in centimeters. So this means we have to convert the length to centimeters so that all the units will be consistent. So which means that you have to know the relationship between meters and centimeters to be able to do the conversion. We also want to report density in grams per cubic centimeters. So that means that we have to change kilograms to grams. And to do this, we have to recall that 1,000 grams equals 1 kilogram. Okay, so once we understand that, then we just proceed to calculate the volume and then proceed to do unit conversions and then calculate the density. Now, the second question is about water displacement. So here, we do have a graduated cylinder that contains 33.8 mils of water. So this is the initial volume of water. And a stone with a mass of 28.4 grams is placed in the cylinder. The new level of water in the cylinder is now 44.1 cubic centimeters. Calculate the density of the stone. So here again, we just have to make sure the units are consistent. And also, we want to report density in grams per cubic centimeter. So this means that we have to make sure that the units are consistent. Here, the initial volume is in mils and the final volume is in cubic centimeters. So we have to convert milliliters to cubic centimeters. But we do know 1 cubic centimeter is equal to 1 milliliter. So this really doesn't change anything. So they are related by 1-to-1 ratio. So only the unit changes, but the value doesn't. Okay. So let's proceed to work these problems. Okay. So let's proceed to work these problems. Okay. So basically our width is 5.1 centimeters. Our length is 1.08 meters, and our height is 6.2 centimeters, and the mass is 2.52 kilograms. Okay. So to find the volume of the block, you just have to recall that length times height times width. Okay, so this equals to 1.08 meters times 6.2 centimeters and times 5.1 centimeters. Okay. Now, as you can see, the units are not consistent because this centimeters, and this meter. So we have to convert this to centimeters as well. Okay. But we do know that 100 centimeters equals to 1 meter. So we can use this to convert that. Okay, so we say volume of block. I'll just convert it here. Then 100 centimeters here over 1 meter. Then I'll close it. Then I'll multiply by 6.2 centimeters, then by 5.1 centimeters. Okay. Now we've done unit conversions before, so just watch that video on unit conversions if this table here is confusing to you. Okay, so common units on a diagonal cancel. Okay. So what I have is I just have to multiply the 1.08 by 100 by 6.2 and by 5.1. Okay. And also the units, the centimeters will multiply also. So that means that centimeters times centimeters times centimeters will give us cubic centimeters as well. So if we multiply all this together, we're going to get 341496. So we're going to get 3414.96 cubic centimeters. Okay. So that is that. Now, if you want to keep track of significant figures, you can do. Okay, because if you look, this has 3, this has 2, this has 2. Okay, this one has infinite number of significant figures. The 100 centimeters equals to 1 meter because it's a definition. Okay, so which means that our least number of significant figures is going to be 2. Okay, so it's going to end here. Okay, yeah. So we just keep track of it. We don't have to round up now. We just have to keep track since we still have to calculate density. Okay, so we still need mass to do that. So we'll put in the right number of significant figures at the end of the calculation. Okay. So that is the volume of the block. So mass, our mass is given in kilograms, but we want to report density in grams per cubic centimeter. So which means we have to convert the kilograms to what? To grams. So we also have to recall that 1,000 grams equal to 1 kilogram. Okay. So once we recall that, we set up the table. So we have our 2.52 here, kilograms. Then we have our 1,000 grams here. Then we have our 1 kilogram. Okay. So kilogram will cancel kilogram. So basically, I'm going to get 252.20 grams. Okay. So that is the mass of my block. Now this one has 3 significant figures. So that means that if you keep track of it, it's going to be on this. So it's going to end here. Okay, it's going to end at 2. Okay, so now let's proceed to calculate our density. Okay, so density, as we recall, is given by mass divided by volume. Okay, I want to report density in grams, and then want to report mass in grams and volume in cubic centimeters. Okay, so let's put in our value. So the mass is giving us 2520 grams divided by our volume, which is 3414.96 cubic centimeters. Okay, so if you divide, you're going to get a long number. Okay, you're going to get from your calculator, it's going to be somewhere like 7379 grams cubic centimeters. Okay, but since we want to put it to, since the least number of significant figures we have, it's 2, that means that we have to round this to 2 significant figures, or 2 decimal places in this case. So it's going to be 0.74 grams cubic centimeters. Yeah, so there you have it. Okay, so that is that. Okay, so let's proceed with the second problem. Okay, so the second problem says that you have a graduated cylinder. You initially have a volume of 33.8 milliliters of water in it, and then you dropped an object in there, and the water level rose to 44.1 cubic centimeters. So we'll call this initial volume. So this is the initial volume of our water. So we call this initial volume V1. And once we put our rock in there, the water level rose to 44.1. So we call this V2. Okay, I'll find out. So this is initial volume of water in a graduated cylinder, and this is final volume with block submerged. Okay, so to find the volume of our rock or stone, we'll do volume of stone is equal to V2 minus V1. So we subtract the small volume from the big volume. So here we're going to get 44.1 cubic centimeters minus 33.8 milliliters. Okay. Now, but we have to make sure the units are consistent. So here we have cubic centimeters, here we have milliliters. So the units are not consistent, they're not the same. So we have to change one of them. Now, since we want to report density in grams per cubic centimeters, that means we have to change the milliliters to cubic centimeters. Okay. And to do that, you just have to recall that 1 cubic centimeter equals to 1 milliliter. So they're in a ratio of 1 to 1. So since they're in a ratio of 1 to 1, yeah, the value really doesn't change, it's just the unit. Okay. So to change it, I just draw my table again. So I put 33.8 milliliters here. Then I put 1 mil and then 1 cubic centimeter here. Okay, close the table. So common units cancel. So basically I'm going to get the same value with a different unit. Okay, so that is that. So you see it? Yeah, so now to get a volume of my rock, I just do volume of stone. It's equal to 44.1 cubic centimeters minus 33.8 cubic centimeters. So if I do this, I'm going to get 10.3 cubic centimeters. Okay. Yeah, since I'm subtracting, it should be in the least number of what? Decimal places. So it's the one, they both have to just one decimal place. So yeah, so this is one decimal place. 10.3. Okay. Yeah, so now we proceed to calculate the density of the rock. Okay, so we want to find density. So density is giving us mass over volume. I want to report units of grams per cubic centimeters. Okay, so we plug in our value. So the mass is already given in grams, so we don't have to do any unit conversion here. So we just put our value, which is 28.4 grams, divided by the volume, which is what we'll calculate as 10.3 cubic centimeters. So if we do, we are going to get 2.76 grams per cubic centimeters. So that is it. Okay. So it is, let me write it again, 2.76 grams per cubic centimeters. Okay. So that is the density. And here, yeah, so we're keeping track of the number of significant figures. Yeah, so in this case, we'll put it to 3 significant figures, which is that. Okay. So this is solving numerical problems involving density. Okay. But sometimes some density problems ask you conceptual questions. So let's try to look at these questions. Okay, but before that, let's look at how to manipulate the density equation. Okay, so we want to apply some algebra here. So we have density equals mass over volume, right? So sometimes you'll be asked to find volume. Here we figured out our mass and our volume and then divided mass over volume to get density. But sometimes they'll give you the density and then they'll give you the mass and then ask you to find volume, question mark. Okay, so how do you go about it? Now to go about it, that means you have to isolate volume, right? So the way to do that is to apply some algebra. Okay, so this is density formula, D equals to M over V. So the D here is standing on top alone, so it's the same as saying D over 1. Okay, so it's on top, so it's the same as saying D over 1. Okay, so that means that if you want to isolate V, you cross multiply. So you cross multiply and then you have D over 1 here. So this means that D times V and then 1 times M. So if you do that, you're going to get dV equals what? M times 1, which is basically M. But we want to isolate V. We want V to stand on top, just alone. So we divide here by D and divide here by D. So D cancel D. So that means that V, volume, is equal to mass over density, D. So if you want volume and you know mass and density, you just divide mass by density and you get volume. Okay. So that is how to isolate V using the density formula. Also, sometimes you know density and you know volume, but they want what? They want you to find mass. So here, density again is over 1. Okay, so you cross multiply like that. So D times V and then m times 1, which is still m. Okay, so here m is standing alone, so you don't have to do anything. It's the same as saying m over 1 or dv over 1. So if you want m, you just multiply density by volume, and that gives you your mass. Okay, so that is how to manipulate the density formula using cross multiplication, okay, and division. Okay, so that's something to keep in mind. Okay, so sometimes, as I pointed out, it's not all the time they ask you to solve numerical density problems. Sometimes they ask you conceptual questions. So let's look at conceptual questions. Okay, so let's say they asked you that why is it that two objects have the same mass but different densities. So you have to go back to the density formula again. Density equals the mass over volume. So density, two objects have different densities but same mass. So why is that? Okay, so they have the same mass but different densities. Yeah, the reason is that the volume is different. So the amount of space they take up is different, which is why even though they have the same mass, they do have different densities because the volume they occupy is different. Okay, so yeah, so volume is accounting for the difference if you have two objects with the same mass but different densities. Okay, so which means that the way the atoms are packed in that given substance varies, even though they have the same mass. So maybe one has a larger volume than the other. Okay, so yeah, so that's how to look at it. Also, you can have d again, m over v. You can have two objects, they have different, so this is different densities, but they have the same volume. So if they have the same volume, then that means that the mass is different. Okay, so they have the same volume but different densities, meaning the mass is different, which means that in one substance you have more matter packed in there or more atoms packed in there, giving it much more mass. Okay, so yeah, so conceptually that is a way to look at it. So yeah, so density, you don't have to always just think of it as just involving numerical problems. You have to also think about it at the molecular level. How are the atoms packed in a given space? Okay, so once you understand that, then yeah, it becomes a lot easier. So that is it. Okay, so to summarize, density is an intensive property. Because of that, it can be used to identify a substance. Density also is temperature dependent. Because of that, it's always good to specify the temperature at which density was determined.